So in this question, let's see what and which test we have to use. The drug 6-MP is used to treat leukemia. The following data represent the remission times, which is in weeks, for a random sample of 21 patients using 6-MP. Now 21 patients. So as soon as you see the terms, just mention. So 21 patients means this is the size of sample. N is 21. Okay. So these are the data given to you. The sample mean is 17.1 weeks with the sample standard deviation as it is approximately equal to 10. Now suppose this is not given to you. As you have the data, it is possible for you to calculate these two values, sample mean and sample standard deviation, by using the formulas for mean and standard deviation. Okay. Now here it's already given, so you don't have to work for it. Next, let x be a random variable representing the remission time for all patients using 6-MP. Assume the x distribution is mound shaped and symmetric. A previously used drug treatment had a mean remission time of mu is equal to 12.5 weeks. So again mu is available here. Do the data indicate that the mean remission time using drug 6-MP is different from 12.5 weeks? So this is your question. So does this data represent that the mean time which is found earlier to be 12.5 weeks, is it different or it's same? And we have to use alpha, the level of significance, as 0.01. So when we have different means not equal to, because they are saying that is it 12.5 weeks or not. Okay. So the very first thing that we have to do is frame the null hypothesis and alternative hypothesis. Null hypothesis, we always agree with the previous results. So we say that okay, previously this drug treatment has a mean remission rate of this, so let's go ahead with this. So mu is 12.5 weeks. Okay. Now if it is not true, then we have to make the test, and for that we will use this. Different means here mu not equal to 12.5 weeks. So this is now two-tailed test. Now what other information we have here? We have information from the population. What do we have from the population? We have population mean, which is 12.5. And from sample, what do we have? We have the sample size, which is n, that is 21. We have the sample mean, which is x bar, which is 17.1. And we have the sample standard deviation s as 10. So now we don't have the population standard deviation, but we do have the sample standard deviation. So we will go for t-test in this case. So now let's calculate the t value. The formula is x bar minus mu. Standard deviation we denote by s times square root of n. The sample standard deviation is denoted by s. So let's put it over here. X bar is 17.1 minus mu is 12.5 divided by s, which is 10, times square root of n, which is 21. When we do the calculation, we will get the value. So this gives you the value 2.1. This is t value. Now we need to calculate, compare this t value from the tabulated value. Now t value to get from the table. So to get the t value from the table, what we need? We need the type of test. So it is two-tailed test. We need alpha, which is 0.01, alpha 0.01 or 1%, and then we have n is 21, right? So to use the t table, we need degree of freedom, which is always n minus 1, which is 21 minus 1. So we have df as 20. So now we consider these three quantities to get the t value from the table. So this is the t table. This is df that we have to check. So our df is 20. Okay. Our type of test was two-tailed. Okay. So 20 means this row. So we need to check that from this row which number we have to select. For two-tailed test, our level of significance 0.01. So our value will be this number, 2.845. This will be our t value from the table. So once again I am saying how we did it. We first check type of test, it is two-tailed. Degree of freedom is 20. So from this row we want to select one number. That number is on the basis of the level of significance, which is 0.01. So intersection of these two comes out to be 2.845. So this is t value from the table. So we got the value from the table as 2.845. So it is 2.845. Now with this t value from the table, we find the critical region. So again we'll use the same concept. Take a line, draw the point 2.845 minus 2.845. Critical region is on the left side of the negative value, on the right side of the positive value. Check our value. Our value is 2.1. Now 2.1, where it lies? Say if this is 0, so it will be somewhere here, approximately 2.1. So again, not lies in the critical region. So now we will say that now we are going to make the conclusion, as t value from calculation is 2.1 and not lies in the critical region, we do not reject the null hypothesis. So it means H naught, that is mu is 12.5 weeks. Mu is equal to 12.5 weeks. It means that the mean remission time using the drug is 12.5 weeks. So hence the mean remission time for 6-MP drug is 12.5 weeks. That's it. Okay. So archaeologists become excited when they find an anomaly in discovered artifacts. The anomaly may or may not indicate a new trading region or a new method of craftsmanship. Suppose the length of projectile points, or also known as arrowheads, at a certain archaeological site have mean length of mu is equal to 2.6 centimeter. See, it's not necessary that it is always given with the symbol mu. Sometimes it's not given that mu equal to this. They say that it may be like what I want to say it may be given that it have the mean length 2.6 centimeter. Then it's understood that it is mu. Okay. A random sample of 61 recently discovered projectile points in an adjacent cliff dwelling gave the following lengths in centimeter. So now this is mu, n is 61. Okay, this is given to you. This data is given. Now the sample mean is given and the sample standard deviation is also given, where x is a random variable that represents the lengths of all projectiles found at the adjacent cliff dwelling site. So suppose the sample mean and sample standard deviation is not given to you, you are still able to find the values by using the formulas. Okay, now do these data indicate that the mean length of projectile point in the adjacent cliff dwelling is longer than 2.6 centimeter? So we now make a testing about the mean length of the projectile points. Okay, so h naught. So for that we need to come up with the null and alternative hypothesis. So first we agree with we go ahead with the previous evidences that mean length is 2.6 centimeter. Then alternative hypothesis, they are talking about longer. Longer means greater than. Mu is greater than 2.6 centimeter. So this is right-tailed, or you can say one-sided test. Okay. Now what else you have? You have mu, n, mean and standard deviation for the sample. So it means you have to go for t-test. So let's solve it. So when we do the t-test, like from population, what we have mu, which is 2.6. From sample, we have sample size 61. We have sample mean and sample standard deviation as mean is 2.92, standard deviation as 0.85. Then calculate the t-value by using the formula x bar minus mu over s times square root of n. So substitute the value 2.92 minus mu, which is 2.6 over s, which is 0.85 times square root of n, which is 61. So this gives you 2.94. This is t value from calculation. Okay, now I want the t value from table. T value from table. So for that what we need? Type of test. It is one-sided. Okay, we need alpha. Alpha is 1%. Alpha is 1%. It means alpha is 0.01. And we need df, degree of freedom, which is n minus 1. Our n is 61. 61 minus 1. So it is 60. So now we have to look at the table for 60. So now it is one tail test. Degree of freedom is 60. So we have 60. And then alpha is 0.01. 0.01 here. So the point of intersection, if we go down from here and from here, so it comes out to be this 2.390. So T is 2.390 from the table. Now we make critical region. Now critical region will be, put the point 2.390. Let's say this is the origin. This is minus 2.390. The region of rejection. This is the region of rejection. Our calculated value 2.94. Now this time what happened? Our calculated value is 2.94 somewhere here. 2.94. It lies in the critical region. This value lies in the critical region, means the region of rejection. So do not accept H naught, the null hypothesis, because our values lies in the critical region. So what was it? So it means when we are not accepting that mu is 2.6 centimeter, we say that mu is greater than 2.6 centimeter. So it is show. So what we can see, we can get the thing is that the mean length of projectile points in the adjacent cliff dwelling is longer than 2.6 centimeter. Okay, so mean length, you have to write all this, of the projectile dwelling in this is longer than 2.6 centimeter. In the similar way we can answer these questions. Okay, here mu is given to you, then reading of 36 waves, so n is given, mean is given, standard deviation now for population is given, so it will come for Z test. Now it is information for increasing, means greater than one-sided. So this is the way how you can work with the statistical hypothesis testing.